In this video, we're going to draw that. And you might think, okay, it looks a little bit weird, but it looks very, very similar to the normal y is equal to x plus 1. And in order to do this, you'll have to kind of understand how to draw straight lines. So there is some videos, and I'll put a link somewhere, maybe there or there, I don't know where, about how to draw linear equations. Now there are three ways. There's the table method, which is very long. There's the gradient intercept method, which is, it's fine, I guess. And then the double intercept method, which is what we're going to use because it's the quickest way to draw these lines. So what we are going to do is, obviously we need a Cartesian plane. Very nice. And just what I would do usually, maybe you're smarter than me and you can do it differently. I'm good for you. But my pro tip would be taking this and kind of rewriting it with an equal sign, because I found students, it's very weird for them to see this and then like know what's going on. So usually I'll say, hey, do the same thing, just write it in this form, and then we're going to draw this line. Okay. One thing to notice is that this is a greater or equal to sign, which means that when we draw a line, it's going to be a solid line. If we're faced with just a greater or a smaller than sign, we're going to have to draw a dashed line, okay, to show that it's not included. Okay, so before we, well, no, let's just quickly start. So the quickest way to draw this is to find the x and y intercept of this. And to find the y intercept, I'm going to make x 0. So x is going to be 0 at my y intercept, because this is y. And everywhere on this line, x is 0. So y is 0 plus 1. So y is 1. So I just go look for 1. And then I draw a little line there. And then for the x-intercept, I'll make y equal to 0. And in this case, if I were to make y 0 here, I'm left with y is x plus 1. And to rearrange that would just be negative 1 is x, or x is negative 1. So wherever negative 1 is, I'll make a little dot. And now I know my line is going to be there. So I'm going to draw the line in a different color. I know I can draw a solid line because that's included. There we go. And now I'm just going to read exactly word for word what it says in the Cambridge, let's say the curriculum. It says shading should be used to represent unwanted regions, which makes sense because we want to kind of be able to see the wanted regions. So the shading part would be unwanted regions. And then in brackets it says, unless otherwise directed in the question. So if nothing is said, we're always going to shade unwanted areas. Okay, so we have our line and we have a solid line because we know it's included. But now the question is, which side do I shade? Now the rule of thumb here is if I have it in standard form, and the two things to kind of look for is having this y alone. The alone part's probably not as important, but as long as it's a positive y, then we can kind of look at this inequality and say, well, y is bigger than whatever this is. And then where will y be bigger? Does y get bigger up top or down bottom? And y is bigger than this is going to be up top. So I'm gonna, the top part of this line is where I will not shade because this is where it's true, and the unwanted part is at the bottom. So I will shade the bottom because if if y is bigger than, y is everywhere bigger above here if I carry on. So y is smaller below the line, so I shade what's below. We can do our little test and we can choose the point 0, 0. And if I were to put 0 in here for my, let's say my y and my x value, then I would be left with, now this is just my little test. I put 0, 0 plus 1, so 0 is bigger than or equal to 1. So if you look at this and you see, well, 0 bigger than 1, that doesn't really make sense. So yes, 0 is not bigger than 1. So this point where I chose my coordinate 0, 0 should be in the unshaded area because the inequality is not true. So, and that's you can see there. So if you didn't know the top and bottom part, maybe you forget, you can always insert 0, 0, and then you can check where that line or where the origin is. If the origin is if it's true, then the origin shouldn't be shaded. If it's false, then the origin should be shaded. And in this case, this is kind of false. So I would expect the origin to be in the non-shaded, in the shaded area. Okay, let's do one more. Okay, let's do 2y is smaller or equal to, let's say, 4x plus 10. Okay, maybe 10 is... Okay, well, we can do 10, that's fine. Cool, so I have my Cartesian plane here. Very nice. I actually have one printed. Let me use the pretty one. Okay. Even have a ruler here. Ooh. Ah, very nice. Let me just get my ruler. Okay. So my tip is always to rewrite this as a normal equation. So I'll do 2y is equal to 4x plus 10. Again, if you don't want to, you don't have to. If you're really confident with your straight lines and everything, you can just quickly do this in your head. But I'm just going step by step because I have to explain it, right? So I don't want to know what 2y is, so I'll have to divide everything by 2 to get y alone. And that would be 5. And now, quickest way to find the x and y intercepts. You can see how really quickly you can do it. If I make x 0, this whole thing will disappear. So y would be equal to 5. So I'm going to look for y is equal to 5. Make a little dot there. And then the next part, if I make y 0, then I'm going to... I should have used a even number. But anyway, this is fine. So I'm going to be left 2x is equal to negative 5, right? Because this is going to become a 0. And then I'm going to take the 5 over. So it's going to be 2x is equal to negative 5. And divide 2 on both sides. And then x would be, not divide by negative 2, sorry. Just divide by normal 2. And then we'll have negative 2.5. And negative 2.5 would be right there. And I would use my trusty ruler. And in this case, I also have an equal or an included. So it's smaller and equal to. So I can draw a solid line. So I'm going to do a solid line. There we go. All drawn. And now I just have to figure out which side to color. Now, either this one or this one will work to figure it out. Because y is alone, which is probably not the most important bit. So I can even if it's 2y, it's fine. As long as this is a positive number and y is positive, then I can say, well, positive y is going to be smaller or equal to. So where will y be smaller? Y will be smaller below, because y gets smaller and smaller as we go down. So this will be true. Y is smaller than everywhere. Oh, I shouldn't have. Oops. That's not going to come out. So y is going to be smaller everywhere here. So I have to draw the opposite, because they shade. Shading should be used to represent the unwanted region. So y is bigger above the line, so I can shade above here. With my pen, you can just do this. This should be fine. Or with a pencil, you can rub. And we can test it again. So we can put in our 0, 0. So I'm kind of expecting if I put 0, 0 in, I'm going to end up with some equation here that's going to look true. So if I put 0 there, I get 0. That is fine. And then that is a 0 plus 10. And if I just take that away, then yes, 0 is indeed smaller than 10. So I'd assume this point would be in an unshaded area, and it is indeed in an unshaded, in an unshaded area. Cool. So in the next video, we're gonna do 2 more trickier examples, and then we're gonna move into the part that we should be able to do is they're gonna give us 3 of these lines, or sometimes even 4, and we have to draw them all on the Cartesian plane, but more of that in the next video.